In this video, we're going to be talking about a type of double replacement reaction called a precipitation reaction. We're going to go over what a precipitation reaction is. We're going to go over how to figure out what the precipitate is in a reaction. And then we're going to go through a new way of writing a chemical equation called a net ionic equation, which is particularly useful for precipitation reactions, and the reason why we want to use these instead of a more traditional molecular equation. Your chart of charges for this would be fantastic because you would need help figuring out which substances will create precipitates. And once you have your stuff ready, let's go. Okay, so first off, a precipitation reaction, again, is a double replacement reaction, and it produces a solid product. Right, so you have to produce a solid for a reaction to be precipitation. So as an example of a precipitation reaction, we have silver nitrate and sodium chloride. Both of those are solutions. We form sodium nitrate, which remains dissolved in solution, and silver chloride, which is a solid. That solid will precipitate out. So what's going to happen is we mix together two colorless solutions, and we wind up getting a white solid, which is our silver chloride. Right, so that is our precipitate. Now, what we should kind of look at is what the reaction looks like. So initially, when we mix these things together, in this reaction, our first solution is going to have silver ions. It's going to have nitrate ions. Our second solution is going to have sodium ions. And it's going to have chloride ions. Right, so all these things are floating around in the solutions before we mix them together. When we do, we're going to have Na ions still in solution, right, because it's still aqueous here, so they still break up. We're going to have NO3 ions right here, again, also aqueous because they're still in solution. And then when a silver ion comes into contact with a chloride ion, they form silver chloride, and that's what winds up forming our solid. So here's how we go about representing a precipitation reaction. We represent them using something called a net ionic equation. The equations that we've been using all year are called molecular equations. You show out the full formula for everything involved in the reaction. The problem is, as we just saw in the previous slide, some of those things don't actually really do anything in solution, right? The sodium ions and the nitrate ions, they started off dissolved in solution. They end dissolved in solution. They didn't really do anything. The only two ions that did something were the silver ions and the chloride ions, and they formed a precipitate, and that's the part of the reaction that we care about. Right, so the goal of a net ionic equation is that it only shows the change that is happening. It ignores everything else in the reaction except for the change that you see. Right? A molecular equation is a great thing. It's great for doing stoichiometry and for figuring out like how much of masses you have to weigh and all that sort of stuff. Net ionics are good at showing you what's actually happening. That's why we use them a lot. Right? Now, again, the sodium and the nitrate, they didn't do anything. They were in solution before, they're in solution after. They just sat there and watched. And if you just sit there and watch, you're going to be a spectator. Right? Net ionic equations do not include spectator substances because they're not involved in the change. So here's how we go about writing a net ionic, and this is going to be the easy way of doing it. First thing we're going to do is start off with a balanced molecular equation just like we've been using all year. Then we're going to figure out what our precipitate is. The precipitate is going to be our product, and we're just going to write it on the product side. After that, we're going to figure out which ions created that precipitate, and those are going to be our reactants. Now keep in mind, you have to make sure you get the charges right. Okay, so make sure you use your chart of charges to figure out the ions. Once you have your two sides of the equation, balance the equation. Net ionic equations have to be balanced for mass, just like every other equation we've worked with. But there's one additional thing now because we're working with charges. You have to balance for charge. The charge of the reactant side has to be the same as the charge on the product side. For precipitation reactions, that will be 0. So 0 on the reactants, 0 on the products. For some equations that we're going to be doing in the next couple of weeks, those sides don't necessarily have to be 0, they just have to be the same. All right, so let's try it with our equation. Right, so we have silver nitrate plus sodium chloride makes sodium nitrate and silver chloride. Well, what's our precipitate here? What is the solid in this reaction? Silver chloride. So we're going to write down silver chloride as our product. Now what we're going to do is we're going to look at the ions that made them. If you remember from the earlier slide, the silver ion is Ag+, the chloride ion is Cl-. Now because the substances that they come from are both aqueous, their state is going to be aqueous, right? They were dissolved in solution. So we have Ag plus Aq, we have Cl minus Aq. Silver plus chloride makes silver chloride. Now what we do is we go through and we make sure that it's balanced. 1 silver, 1 silver, 1 chloride, 1 chloride. What I would do is I would just put a coefficient in front of these for however many I needed in this formula. Keep in mind, when you're writing the formula for your products, you have to drop and swap everything. This is why you need your chart of charges. To figure out if something is a precipitate, you need the solubility table on your chart of charges. Right? So look it up. If we look up silver chloride, silver on the left-hand column, chloride on the top, where the box meets, it will say solid. All right, so how about one for you guys to try? Right, I want you to try potassium sulfate plus barium chloride. Now, take a minute or so, get the balanced chemical equation for this. We'll get back and we'll go over that. Then I'll give you another quick pause so you can write down your net ionic. So figure that out, take a couple of minutes. Okay, so hopefully you're back from pausing. Right, this is double replacement. Double replacement, remember, means outer 2 and inner 2. Right, so the two ions that are going to combine, we're going to have barium combining with sulfate, potassium combining with chloride. Subscripts do not carry across the arrow unless they're part of a group. Right, so the 4 carries across because it's part of sulfate. The 2 for potassium and the 2 for chloride don't. They're just there to drop and swap. Right, so what we'll do is we'll take our potassium, K's charge is +1, Cl's charge is -1, it's balanced. Then we'll take our other combination. Barium gets written first because it's the positive. Barium is +2. Sulfate is -2. So barium sulfate is correctly written. We'll balance this for mass. Pretty simple balance. I'll put a 2 right there. And then we'll go for charge. Or sorry, not for charge, for states. Potassium chloride, if we look that up, potassium chloride is soluble, so it's aqueous. Barium sulfate is not. So now that we have this, what I want you to do is I want you to write the reaction for the formation of barium sulfate. Take a few seconds on that. Okay, so our net ionic equation. Our precipitate is barium sulfate, so I'm going to say BaSO4 solid. The two ions that make this. Now, generally, we write the positive charge first, even though it's not written first over here. I'm not going to worry too much if you write them whichever way. Right, but the way that we're usually taught to do it is we're going to have barium, which is a 2+ ion, and that's aqueous, plus sulfate, which is a 2- ion, also aqueous. This is balanced for mass. It's balanced for charge. This is our net ionic equation for this precipitation reaction. The next video will be talking about concentrations. I will see you guys in class.